technical session. It is majorly on the bridges. And the session chair is Mr. Ninan Koshi. May I request him to kindly come on the dais, please? Sir, please. And the co-session is, session chair is from Japan. Mic is not, it's working. मुझे नाम दो उनका नहीं, उनका वो ला दो आप चलेगा. So I invite the session chair of this technical session, Mr. Ninan Koshi. Sir, please come on the dais. And the co-session chair for this session is Mr. Kiyoshi Dachiku from Japan. Can we welcome our session chair and co-session chair with a round of applause, please? There are 6 papers in this session, and the first paper is analysis of partially pre-stressed beams serviceability limit state by Shri T. Vishwanathan. Can he come on the stage, Mr. T. Vishwanathan? The second paper is by Mr. Surender Singh, Dr. G.D. Ranchuk, RN, Shri Kumar and Dr. M. Parida. So I request all the authors to come on the dais, please. The third paper is by K.P. Abraham, Shri R.C. Sharma, Shri Manish Krishna and Shri Surjit Chakravarti. I think the remaining authors will be will come on the stage after the tea break. So we can, sir, can we start the session? Koshi sir, now the session is all yours. So before the tea break, sir, like 3 papers will be before tea break and 3 papers after the tea break. They are meeting.
First thing I want to know. First thing I want to know is it's not working.
Check, check, check. Check, check.
First thing I want to know. Working? Can you hear me? Okay. First thing I want to know, what is the timing of this session? It is all upset. Whatever you gave in the paper is not there.
Check.
When are you starting? Time is 11:45. You tell me up to what time I am to conduct this. 1:30. Yeah. Welcome, delegates. We are starting this session. It is little more than half an hour late, so we'll have to adjust the timing accordingly as we proceed. So we have, how many papers are there in this session? 6 papers. Okay. Six papers are there. I will call upon each one of them to start presentation without wasting any more time. First presenter is Mr. T. Vishwanathan. He is presenting a paper on the analysis of partially pre-stressed beams serviceability limit state. Slot given is, in this paper it is given as 20 minutes, but I think you'll have to restrict it to about, so what, 15 minutes?
Try. I will try.
Please try, please try. Thank you. Mr. Vishwanathan is a senior consulting engineer in the bridges side for many years, and he has been the member secretary of the B4 committee of IRC, which brought out the code IRC 112 on the limit state design. He has been instrumental in throughout the drafting of the code, and he has also been instrumental in
Where is my presentation?
drawing up the explanatory handbook on that code. Mr. Vishwanathan.
I sent it to a long time back to IRC.
Where is he? Please start.
You have this? Yeah.
So did you load the presentation?
No, I just sent it to IRC. They asked me all my presentations. I sent it to IRC. Long time back.
Which one, sir? Analysis.
Analysis of partial. No, I will open it. I will go open the serial.
Okay, sir. What happens is I'll open it and put on the desktop. Reading from CD will
You
be
start with this one. Other articles of IRC. No, you have to copy all the this thing.
Yeah, I'm commenting, sir. So this is one after the other, sir.
This is
Which one, sir?
While it is getting ready, let me introduce my co-chairman here,
Which one I have to open?
Mr. Kiyoshi Dachiku, who is from Japan, and he has been in Delhi for many years as representative of the JICA
It
organization,
is not in a
Japanese
PDF format,
International
sir.
Cooperation
This one.
Agency. Now he has left that agency and he still continues to work in Delhi for another
This one, sir. This
consultant,
is
Other articles.
Mr. Kiyoshi Dachika.
It will be PDF.
Hmm.
You don't have PDF format. Okay, then Word format is there. No?
Ah, what is this?
Okay, and then you open the other
Final
my
analysis.
article, finally analysis this.
This one, sir.
We are losing valuable time, Mr. Vishwanathan.
The problem is, sir, they
Oh, sir.
wanted me to send my presentation. I sent it 1 month back. It has not been loaded.
Yes, sir. That's okay, man. You don't.
Now they are telling PDF format is not there. They cannot open.
Check. Sir, this Word file is loaded. Madam, speak very closely like this. Check.
Okay. Sir, can we start with the second presenter in the meantime?
No, that's okay. It's
You
open.
can? Okay. Sir, just a minute. Actually, I have just been told by the organizers that we have to welcome the session chair and co-session chair by a bouquet. So I ask them to do it quickly. Kindly welcome the session chair and co-session chair by the bouquet of the flowers. Please hurry up. Please. Sir, please. वैसे ही टाइम नहीं है. Yeah, please.
After this, I have to close, then open the PPT. Yes. You want me to restrict that also ready?
It's two only. Okay, now the session can go.
Yeah.
Please, please. Sorry, sir.
No, no problem.
There is some confusion.
They should have loaded it. You see, this one,
No, sir, it is already open.
It's already open.
Yeah.
Okay, I will close it and open it.
Editorial is now open.
Editorial is also to be open.
Okay.
Yeah, yeah.
It's open, sir.
Yeah, okay.
Now, 2 files are here. Third file is your this thing.
Okay.
Right, sir?
Okay. You start with the other file.
Which one, sir?
That one.
Come little closer, sir. Please be little closer.
Where is it? I can see this, no? Okay. Good morning, ladies and gentlemen.
Little closer, sir.
I am going to present my paper, Analysis of Partially Pre-stressed Beams, Serviceability Limit State. This analysis is based on IRC-112. The last time I presented a paper was in the same city of Hyderabad in the year 1999. The paper was chaired by the chairman. The paper myself, Mr. Koshi, jointly wrote Analysis and Design of Foundations under Artesian Conditions in the 1999. Today I am fortunate. I am having Mr. Koshi as a convener for this session, and also incidentally he was the convener for publishing IRC 112. So he is associated with this code more than for 25-30 years code, 35 years with the Reinforced Concrete Committee. So we start with our this paper. First I will run through my paper, then I will go to PowerPoint presentation. So what is a partially pre-stressed beams? Partially pre-stressed beam is defined as per the ASTO that under serviceability limit states, the tensile stresses are within the allowable limits, then it is taken as partially pre-stressed. If the tensile stresses are exceeding the limit, then you have to add the non-tensioned steel, so it becomes partially pre-stressed beam. This is the definition given in ASTO. Now, IRC has allowed partially pre-stressed beams, but for a designer, they will find it difficult how to go and check the partially pre-stressed beams. It is not because it is a problems I will explain what is going to happen with these partially pre-stressed beams. Before that, what are the checks you have to make? I will quickly run. One is the stress check. You have to carry out the stress check. Second is you have to calculate the crack widths. And you have to calculate the deflection check, and you have to do fatigue verification. It amounts to four checks. That is stress check, crack width, deflection, and fatigue verification. If you do these 4, then your partially pre-stressed beams for serviceability limit state is okay. The fatigue verification, as per the Eurocode and CEB FIP model code, it is taken as ultimate state, where ASTO puts it under serviceability limit state only, the fatigue check also. So now, how do you do this approach? I had given first the general approach. How do you analyze the section? In this case, you will find there are 3 problems will arise. Part of the load is applied on the precast section where the section is not cracked. Then part of the load is applied in the composite section. The section may crack or section may not crack. Lastly, you will find when the live load comes, the crack takes place. So the pattern, the cross section is not remaining constant. It is at one state, some particular partial load is added on the part of a section. The second stage you add more load on the section, but the section is changed, and the third place you find the section is cracked. So now what is the readjustment takes place for the loads which has already been applied? This is what the analysis is involved. So first what you have to do is, when you analyze the stress, prove that it is cracked. If you see this table which I had given in my article, it gives you the tensile stress per meter is 330 ton per meter square, but whereas the tensile stress registered is 419 ton per meter square. That means you have proved that the section is cracked already. So the full section, you cannot, normally what you are taking is the full section you are taking and analyzing it. So it is not possible. It is remaining as an uncracked state when the dead loads and live loads are, dead loads is applied. When the live load is applied, it cracks. So the question comes, what kind of a property you have to use? This is a very big confusion even in IRC-112. We have written that the stress to be checked and deflection to be checked in case FCTM, the tensile stresses are within the limits, you can take full section. But there are cases is going to come, when you check the stress, you may get the section cracked. But when you come to deflection and crack width check, the section may not crack. For this, the ASTO says, when you see a section which is going to be cracked under particular loading conditions, right from the beginning itself you neglect the tensile stresses and carry out as a cracked section analysis. The French has given a modification in their EC2 guidelines CETRA publication. If you happen to have a situation like that, under frequent combination of the load, the section doesn't crack, whereas in the rare combination or basic combination, the section cracks. Then it is better to omit that the tensile stresses of concrete, even doing a frequent load combination, or for your deflection check and crack width check, use only the cracked section. This is what the recommendation has been given in the CETRA. I think that is a very right specification. Though our code is silent, we may have to bring it to this particular clarification later on. Now there is another term which has been defined in the ASTO code, or in the what is called in our code also it is there. What is called as a decompression stress in the steel, decompression, when the decompression takes place. That means when all the compression is eaten away and the tensile stress is going to, the section has cracked, what kind of a stress, steel, what is the pre-stressing steel is going to have, that is called as a decompression state of stress. That is defined in my article as DSC. How to calculate the DSC? That we will see in the PowerPoint presentation. So you have to start the point what the pre-stressing steel is having the force at that time surrounding the concrete, the stresses are 0. Now once you calculate the de-stressing state, then you have the reinforcing steel. The reinforcing steel normally we neglect it, but reinforcing steel will have stresses developed due to creep and shrinkage. So you are going to get an additional force in the pre-stressing steel due to shrinkage and creep stress, and also the decompression state of stress also will come inside this steel. Under this steel, under these forces, you have to analyze the section. Now I have given the method of analysis in my paper, the stresses developed in the pre-stressing steel, and also the stresses developed in the reinforcement steel. Method of analysis, which I will try to, I have worked out the example and given you the method of analysis. The method of analysis is called as the bare beam approach. The bare beam approach is one where first you have to take the beam, apply the load and put the decompression stress, find out the stress, and then fictitiously you assume that what is the stress in the slab, you calculate it, and then when you are putting it on the composite section, this fictitious force and the decompressive stress and the load applied on the precast beam, you will end up the same state of stress, which I can show you. At the same state of stress you will reach as if it was a bare beam applied. So this is called as the bare beam applied, the bare beam approach. Once you have this force and the composite section, now you apply the total moment and find out the cracked section properties, and then analyze the section, check the stresses and deflection and the crack width. And also you can, if you are intelligent, you can check the fatigue analysis also. This is what I have done in my paper. So this is quickly I will go through the PowerPoint presentation, because it becomes difficult to go through the entire paper, which I presume the authors must have, the participant must have read my article, which was published long time back. Unfortunately, I have written this article in 2014, sent to IRC in 2014, but it got published in 2016. I am presenting in 2017. Even to recollect what I have written, it has taken a lot of time. However, I will try to explain very clearly so that you can do the analysis in your design office. Now we will go to now I am checking the stresses. Once I have checked the stresses, next I will do, these are all checked for stresses. Once the stress is checked, then I am checking the equilibrium. Once the equilibrium is done, I have taken the crack width check. Once the crack width check is made, I am checking the deflection, and that will end the analysis of the serviceability limit state. Now we will go to conclusion. Conclusion we can see in the PowerPoint presentation.
5 minutes is okay. 5 minutes more. Is it okay?
Sir, give me 10 minutes, I will present the PowerPoint presentation.
Okay.
Okay. Can you just check that?